All right, let's go ahead and get started with our lesson 1-4 video notes over angle measures. In the past, we have measured line segments in previous lessons. Now we're going to measure and classify angles. And we're also going to identify and use congruent angles and the bisector of an angle. And here's a list of your vocabulary terms that are new in this lesson. You will want to make sure these all get copied down in your vocab notebook. And so if you want to use this, take a quick screenshot or pause the video to help you understand which terms you need to have definitions for in your vocab book, then you can do that. Otherwise, we will move right along. All right, first, let me zoom in a little bit because it's a little small to read. Here we go. We are going to be taking a look at the words ray and opposite rays, and you might remember some of this from the past, but a ray is a part of a line that starts at an endpoint and extends forever in one direction. Okay, so as our diagram indicates here, this is a ray. We'd have an endpoint M going through points O and P. We could call this ray MP, or using our notation with a ray line above it, just the line with one arrow at one end, it'll always point to the right, never to the left, always to the right, no matter which direction our ray goes. Or I could call it ray MO, or using the ray notation. I will almost always use the ray notation above it. All right. And then we have what are considered opposite rays. Opposite rays are two rays that have a common endpoint and they form a line. Okay, so here we have JH. Even though H comes before J as we read this left to right here in the diagram, we still call it ray JH. J is the endpoint we're using. And then JK, those are considered opposite rays because they are collinear, they form a line. Now, if two rays have a common endpoint and do not form a line, they form an angle. Two non-collinear rays that have a common endpoint. All right? And the vertex of that angle is that common endpoint. And so in our picture here, we have this angle, and we use an angle symbol like this. This is our angle symbol, or you'll often see it with a little arc going through that. And this means angle, and we read it as the word angle. And sometimes we number those angles, so I could call it angle 1, or I could call it by its points. The point S on one ray, R is the vertex, and point T is the other ray. We always will put the vertex letter in the middle of the three letters, so I could call it angle SRT, or angle TRS, but never angle RST, because R is not on the ray, it is the vertex. It's the endpoint of both rays. All right. So we're going to take a look at this first example in which we are asked to name some angles. So part A wants you to name all the angles that have K as a vertex. Well, K is our vertex right there. We have this angle formed by these streets, angle 6, and the other side, angle 8. And technically, opposite rays KH and KC do form what's called a straight angle, so I could also say angle HKC. It's a straight angle that we'll learn about later. When we have opposite rays that form a straight line, we can also call that a straight angle. We want to name the sides of angle 6. We've already been kind of looking there. One side of angle 6 is ray KJ. K is the vertex, so K is your endpoint of your ray. And then the other side of angle 6 is ray KC or KG. We'll call it KC because that's the closest. All right? Those are the sides that form angle 6. Sides of an angle are either segments, or most of the time we will consider those to be rays. Part C, what is another name for angle AJK? Angle AJK. Tracing it will help you determine which angle that is they're talking about. So if we would just trace it, AJK, you can see that's this angle. J is the vertex because it's the middle letter, so we know that's also angle 9. So another name for angle AJK is angle 9. All right, and then lastly, we want to talk about naming a point in the interior of angle ECG. So I'm going to trace that one also. ECG, that's angle 3, and a point on the interior. I kind of forgot to mention that with the last paper I had, so let me show you that. The interior of an angle is all of the space that is enclosed by those two rays. And so anything that goes around the outside is the exterior, and this is the interior. Okay, so we have angles ECG, so anything in this open space here is considered on the interior, and we see that we have point F on the interior. All right, let's move right along. Example 2. We're going to use this image to name some sides of different angles and name some other things. So we want to find angle 5, and again I'll highlight that for you. Here's angle 5. That's formed by these rays. Since angle 5 is formed by those, we want to name the sides. Those are rays. B is the vertex of your angle, so B is the endpoint of each ray. One ray goes from B through G. The other ray goes from B through E or F. E is the closest, so I'll use that. That's just my personal preference. There's no real reason why you would choose E before F. Part B, what is another name for angle 7? Well, let's find angle 7. That's on the exact opposite side of angle 5. And so another name for that angle uses those letters. B is the vertex, so it's the middle letter, so I could call this angle ABD. Or you could change those around as long as B is still in the center and say angle DBA. It's up to you. Most of the time we'll just recognize the first one we see. All right. Now, when we talk about angles, we can classify angles. I do want to quickly mention this part of your notes here. It's called the protractor postulate, and it basically just says if I have some line AB where point O is somewhere on that line, I could draw rays from point O to map to a 1-to-1 correspondence with the real numbers from 0 to 180. It basically allows us to have a protractor set up, and I'll show you what that is right now. This is a protractor, which you've seen before. Not a compass, that's another tool we'll use later. This is a protractor. And so basically, if I were calling this my point O, all of these rays going all the way from 0 around to 180 allow us to have a measuring tool for angles. And so any angles whose measures are between 0 degrees and 90 are considered acute angles. Any measure that is exactly 90 is always called a right angle, which you guys know. Any measure greater than 90, but still less than a full 180, is called an obtuse angle. And then a straight angle, like I mentioned earlier, is two opposite rays, measuring exactly 180 degrees. Okay. So here's what we're going to do. I'm going to use this protractor, and you just need to follow along. Unless you have your own protractor you can use at home, which I doubt you do, but you might. We're going to classify first of all and look at some notations, especially for right angles, that help us see this. So first let's look at angle ABD. B has to be the vertex, and you'll see B is the vertex of just about all of these angles. So ABD forms this angle, and this little box in the corner makes it a right angle. Anytime we have a box in the corner like that, we automatically know it is a right angle, and the measure of angle ABD is equal to 90 degrees. Now notice how I wrote that. This M stands for the word measure, and then our angle symbol, and ABD. We would read this as the measure of angle ABD equals 90 degrees. All right, then let's look at ABC. ABC is less than that full right angle, so it is an acute angle. And then we could measure that. And for the rest of these measurements, we're actually going to save some video time by doing these measurements in class when you can use your own protractor in class. I have a set of these that I will let you use. And so we're not going to do the measuring part of that. We will come back to that in class. So you can leave that part blank. But we can still classify these because we know what a right angle is. And so angle ABF is next. We're going to go from AB out here to F, and that carries on beyond that 90 degrees, so we know that's obtuse. And then ABG forms this pair of opposite rays, so that is a straight angle. And again, we'll find these measurements, and we know the straight angle measurement. The measure of ABG is 180 degrees. But we'll find these two acute and obtuse angles in class. All right, now if two angles have the same measure, we call them congruent angles. That's another vocab term. So if angles are congruent, they have the same measure. Just like if segments are congruent, they have equal length. We measure angles in degrees, and we use these arc marks to show that angles are congruent in a diagram. And so if the measure of angle ABC equals the measure of angle DEF, we would read that exactly like I just said it. The measure of angle ABC is equal to the measure of angle DEF. But then we could read this one as angle ABC is congruent to angle DEF. We don't want to say they're equal if we're using the angle symbol. We want to say equal if we have measure of angles given. All right, which is exactly what you just saw. Sorry, I duplicated that page. We have that already filled out, but I do want you to see this. Since angles have the same measure, since these angles have the same measure, the angles are congruent. All right, so in example 4, we're given this diagram, and we want to recognize that angle ABD is congruent to angle FHG. So I'm going to mark that on the diagram. ABD, that angle, is congruent to FHG. FHG. So we mark those two angles congruent with these arc marks. But then they say if the measure of ABD is 3x plus 6 degrees, and the measure of FHG is x plus 26 degrees, find the measures in actual degrees. We can do this because of our definition of congruent angles. Since they're congruent, their measures are equal. So I can go ahead and say that 3x plus 6 equals x plus 26 because they're congruent. And then I just solve the equation for x. If we subtract x from both sides, we get 2x plus 6 equals 26. Subtract 6 from both sides, and 2x equals 20. Divide by 2, that means x is 10. But the final answer is going to be the measure of each of these, so I'm going to plug 10 in here. 3 times 10 plus 6, 3 times 10 is 30, plus 6 is 36. So the measure of angle ABD equals 36 degrees, and since they're congruent, that's what the other angle measure has to be. And you can test it. We would do 10 plus 26, that's also 36. But you only have to do the calculation once, really. All right, drawing to the end here, we have what is called the angle addition postulate, which is very similar to the segment addition postulate from a previous lesson, but it basically says the same thing, only with angles as the topic. We're going to notice that if I have another point on the interior of another angle and I draw a ray from the vertex through that other point, it creates two smaller angles whose measures still add up to the entire angle. So the measure of angle PQS plus the measure of angle SQR has to equal the measure of angle PQR. And so that is what helps us to complete our notes. Now, this video is running kind of long, so we're not going to be able to cover all of this. We will cover more of it in class, but we can set up this first one. Here's what we know. DEF is 48 degrees, and FEG is 67 degrees. That means that their total is the sum of those two measures. Measure of angle DEG, then, is 115 degrees. All right? So we're going to talk about an angle bisector and finish out example 6 in class. There's a little bit left in our notes that we haven't covered in the video, but this should get you started.